Dear student, welcome again to the next chapter of Pharmaceutical Engineering, Unit 1, that is size separation. We had discussed a lot of many things for size reduction. After size reduction, the process is for size separation. So we must be know about how the size separation could be carried it out. Before going in detail, one must clear to understand about the syllabus content for size separation, the objective for size separation, application and mechanism of size separation, official standards of powder, sieve, size separation principle, construction, working, uses, merits and demerits of sieve shaker, cyclone separator, air separator, bag filter and illustration tank. These are the major content as per the syllabus stated by the university. Now we'll start with the content of this size separation. What is size separation? We know very well about when anything at our home we want to make it separate it out when something is getting mixed together by accidentally or eventually, then we are using certain elements or certain equipments to get it. In simple word, I should say sieve at our home during making chapati. We are using it. So why we are using it? Because we want to just clear it out the mass of material that should be avoid of unwanted things. So in the size separation, the same thing is going to be happen when this material which is not required for our purpose, then we must have to carry out the size separation. So it's a kind of unit operation that involves the separation of mixture of various size of particle into two or more portion by means of screening surface. What is called as a screening surface? It is nothing but the kind of just like a sieve where we are blending or where we are adding something, and this sieve surface by means of their aperture size or sieve number, we are getting the segregation of the material or the raw material or powder, whatever is going for the size separation. This process is also known as sieving, sifting, classifying or screening, because we are using some media through which the materials or the particles or the powder materials are getting classified into various size. Say for example, there are many numbers of the sieves which are available: 10 mesh, 22 mesh, 60 mesh, 80 mesh. These sieve number indicate the specific aperture size. The size may be more, size may be less. If you say that more number of the sieve, that indicate less number of the aperture size. If you say about large number or the small number of the sieve, that indicate the large aperture size. So we should keep in our mind while classifying the powder how the set of the sieve should be arranged as per our requirement. Now if you look into the official standard, with the Indian Pharmacopoeia also state the degree of coarseness of the fineness of powder is differentiated and expressed in terms of their size or by means of their mesh size of the powder for classifying into different category. This classified indicate that what grade of powder actually you require. It may be of millimeter size, micron size, and depending upon the aperture size, we are getting the different grade of powder when we are having a heterogeneous mixture of powder materials, maybe of large size, medium size or small size. So IP has given a specific grade of the powder in terms of coarse powder, then fine powder, very fine powder, likewise, and we can classify this powder according to that category. Now if you look into the official guideline, they have been stated the specific grade of the powder. Just I want to share about that things in detail. The official grade of powder indicate the coarse powder where there is a stated limit. The powder must pass through the given number of sieve, that is the specific grade of the sieve, and they should not be passed through a next grade of the sieve which has the less aperture size and should not be retained more than 40%. So likewise we can pass the different grade of powder Say for example, if you take a grade of powder for coarse material, then as per this table indicate the sieve through which all particle must pass, like 10 number of sieve. But on the other side, the sieve through which not more than 40% of the particles should pass, that is 45. This is the limit within which we are going to collect our powder material, and that powder material is categorized as a coarse powder. Is likewise you can say about moderately coarse, then they should easily pass through 22 mesh of the sieve, and they must not pass more than 40% of this overall powder through 60 mesh. Likewise moderately fine, if you are talking 44 and 85, 45 by 85. For fine powder, if you are talking, then it should be for 85, and it is not been specified as per the standard which is given in Indian Pharmacopoeia. When we talk about very fine powder, they must pass all the powder through 120 mesh, but there is no limit, because this is the limits for powder that could not be passed, then next limit of the sieve, which is not been described in official standard. Now what are the official standard of powder? According to that table, we are going to define the different category of the powder, and every student should understand the type of definition of each and every powders according to their aperture size of the sieve or sieve number. And it is better to understand the sieve number with respect to their size, with respect to their powder fineness. So in usual way, the students are sometime may or may not be aware about the oversize and undersize. What is called as oversize? The particle that get remain on the screening surface, that is called as oversize, and the particle those who are not remaining on the surface is called as a undersize. So according to that, we can define the different grade of powder. So it should be very clear in the mind of a student that what is called as a oversize, undersize, coarse powder, moderately coarse powder, moderately fine powder, very fine powder, or a fine powder. According to the sieve number, we have defined the different grade of the powders. Now come to the point of objective of size separation. What are the major objective? When we talk about the uniformity of material, uniformity of even dosage form or content, then size separation is a great deal for that uniformity. So size separation are frequently used to maintain the uniformity of material as well as for dosage form. Second objective is to remove the undesirable substance. It is one of the most important objective of the size separations. Then next is age of mixing. As like we have already discussed in size reduction, the size separation is also important for the mixing. If the particles are of varying in size and shape, then they will cause the complication during the process of mixing. So one should avoid this kind of mixing process and should carry out the mixing with unique size of the particles of powder, and that's why the need of size separation. Next one is the stability of formulation is of course affected by this powder material size. So stability can be enhanced if we are using the size separation process and keeping the powder material as such in the unique size and shape. That is more desirable in the stability of suspension. If you talk about the liquid formulation, that is also very much important in case of emulsion, when we talk about the liquid as a particles or liquid as a one of the substance for making that formulation. Next objective is to maintain the weight variations. Particle size are great deal with the weight variation, so it is required to maintain the weight variation by physically segregation of or classifying the different grade of powder, and we should be taken out those category of the powder which can uniquely flow while the processing. Say for example, in case of tablet manufacturing, granules must required to size separate by passing through appropriate sieve number to maintain the unique flow property, and that will be required to maintain the unique volume to be filled in each die, and that's why we are getting the tablet of unique size. That is what the main reason why we are using the size separation. And last one is the flow property. Flow property get affected by varying in size of the powder mixture also. So when we go for size separation, the flow property of the powder material can be maintained and we can uniquely formulate that dosage form. Next point is application of size separation. Why we do and why we learn this size separation? To prepare the granules of desired size, as we have discussed in the tablet formulation, the size of granule must be prepared in unique way, so the tablet will be compress it out in without any weight variation. To separate the undesirable particle, to measure the particle size and size distribution, so we can classify the powder and we can categorize that powder, whether it is coarse powders, fine powder, very fine powder, moderately coarse powder, likewise. To get the uniform dosage form and to monitor the particle undergo the less segregation during the processing or unit operation, sometime it is happen that many kind of complication will be observed due to the particle size and shape. If they are in unique, then there will be a less chances that the unit operation will be stuck up. So that's why we are using the size separation. And uniformity of weight and content, as we discussed earlier, it must be required to apply the size separation. Now we are talking about the mechanism of size separation. There are three basic mechanisms through which the size separation is occur. One is agitation, second one is brushing, third one is the centrifugal force. When we talk about the agitation, it may be of different types of agitation. One may use the oscillation, one may use the vibration, and one may use the gyration. What is called as oscillation? It is nothing but the kind of oscillate back and forth, means upward and backward movement of the kind of instrument where the particles are segregated from each other and we are getting the size separation. When we talk about the vibration motion is applied to that equipment. That's why the particles are classified in terms of their various size, where the vibration equipments are usually connected with the electricity, or sometime by mechanically we can connect this equipment and we can carry out the vibration. Third one is the gyration. The rubber mounted and connected to the eccentric flywheel is generally used. The gyration is nothing but the kind of impaction is given to the machine, and through that impaction we are passing the particle to the appropriate number of the sieve, and that's why we are getting the size separation. Second one is the brushing. Is very simple operation. Even we can use it at our home. Many times we are using various kind of brushes for getting that particle to be come out through the nominal aperture size of the sieve, where brush role is that to break down the clogging of the sieve. Sometimes the brush will also produce a minimum pressure to cause the kind of particle to be just come out through that aperture size, and we are getting the size separation. And third one is the centrifugal force, where we are using the externally generated force, or that is so called as a centrifugal force, where all the particles are moving sometime upward, and based on the density of that particles, the particles are classified into the classifier, and we are getting the various size of different grade of particles. So this is what about the different mechanism through which the size separation is occur. What we learned something about the advantage, what we had talked about the objective, we had discussion about the definition, we had a most important discussion about the official grade of the different powder and their stated statement. This is what about the size separation part. Thank you very much.